feedbacks, and we're going to see how diversity creates robustness. First, I want to see how variation produces robustness. Now, what do I mean by robustness? I mean the ability to maintain some sort of functionality despite a disturbance. So suppose you have a screw loose, not in your head, but at home. If you've got a screw loose and you only had a single screwdriver, it may be that the shaft is too short or the blade is too wide or it's too narrow to fit in the screw head or something. It might not work. But if you've got a lot of variation in your screwdrivers, say a set of 12, you're bound to have one that fits. Variation in your collection of screwdrivers enables you to respond regardless of which screw is loose. We've already talked about this, but in evolutionary systems, genetic variation plays this same role. Recall the opening to this lecture, that there is no indigo bunting per se, but there's a population of birds that we call indigo buntings, and that population has variation. It's that variation that enables the population to be robust to environmental changes, the differences in beak length and beak strength. Okay, so variation clearly matters. What about diversity itself? Does it enhance robustness? Yes, absolutely. Let's go back to this analogy of sort of toolboxes. If we have more types of tools, hammers, saws, screwdrivers, even axes, then we're more likely to be able to solve or cope with any problem. The same is true in an ecosystem. The more species, the more likely that some, or at least one, is going to survive some sort of change in the environment, say a climatic change. Example, if your garden consists of only roses and the year is very, very wet, then it's going to be the case that your rose bushes may all rot. But if your garden has many varieties of plants, it's likely that at least some of them are going to survive. The idea that the more types there are, the more responses you get, and the more robust the system is, underpins the concept of requisite variety. Requisite variety says that robustness requires, for every disturbance, there must exist a response. If it rains, you need an umbrella. If it snows, you need a shovel. If you've got a screw loose, you need a screwdriver. This makes sense. But there's bigger fish to fry here, literally. Recall our discussion previously about Robert May's modeling showing how diversity reduces robustness and the contradictory empirical evidence. The fact that the relationship between diversity and robustness is an open question hints at the limitations of these sort of one-dimensional characterizations. Complexity has many dimensions and many definitions, as does diversity, as does robustness. So to say diversity improves robustness in complex systems is to speak very crudely. And what we need is more careful thinking and more innovative modeling. So in coming lectures, we're going to see some research that moves in that direction. That's going to be particularly true when we talk about feedbacks. We're going to see how diversity plays both roles. For now, though, let's just exhale and rest a bit and revel, I think intellectually at least, in the challenging questions that are before us. And we'll try and contemplate, as we move forward, this interesting and challenging relationship between diversity and complexity. Now, in the next lecture, we're going to look at another aspect of complexity, the question of balancing the search for better solutions against the likelihood of finding them. Thank you.